All right, so we are live. Welcome everybody to this webinar. We'll just give this a few more minutes to allow people to join. If you want to say hi, please feel free to use the chat function and say hi. Maybe say where you are, from where you are watching this. Just for your information, this meeting is being recorded. So you'll all get a recording afterwards via email. This will most likely happen tomorrow. There's also a Q&A functionality activated in this Zoom meeting. So if you have questions during Thomas' presentation, then obviously you can post them to the chat, but they might get lost there. If you want to make sure they will get answers, then please put them into the Q&A session. It's much easier to follow questions there than it is from the chat. So we wait for a few more minutes before we get started to allow people to join. And I already see people from many different places saying hi. That's nice. Welcome, everybody. I think it's a super important topic, an interesting topic that we are going to speak about. I heard Thomas' presentation, I think something like 2 weeks back, Thomas, is that right? Yeah. Almost the Berlin meetup. Yeah, something like 2 weeks back, and it's really cool. All right, so maybe repeating myself a bit, this meeting is being recorded. You'll all receive a recording afterwards. There's a chat that many of you already found and used to say hi. That's great. If you have questions for Thomas during his presentation, then feel free to put them into the Q&A section. That way, it's much easier to answer them in the end. And with that, I think we're ready to start. So welcome again, everybody. My name is Christoph. I'm CEO and co-founder of Humanitech. At Humanitech, we are helping teams to build their own internal developer platforms, and we're doing a lot with Kubernetes. And that's how we met Thomas. And we're amazed by his talk about security in Kubernetes, because that's one very important aspect, obviously, dealing with this technology. So welcome, Thomas. I'll let you introduce yourself. So I hand over to you for an introduction, and I'll shut up. I just collect questions and then ask, come back in the Q&A at the end of your presentation.
Yeah, hello, welcome everybody, and so many people joining. Yes, a lot of people. Thanks for your interest. I hope I can keep the promises. And let's go. So this talk is about Kubernetes security. We will do a little bit hacking of containers in this webinar. And that's me. I'm one of the partners of Endocode. I'm a freelancer. I'm doing system automation for years now. At the moment, main topic is DevSecOps, so the security first. And I will tell you why this is important. I'm working in clouds, databases, and as a software architect. Started quite early with Kubernetes, so this is CoreOS. I think, can everybody see my CoreOS t-shirt? It's one of these rare t-shirts you get only on meetings with CoreOS, which is history now, so it's quite valuable. I've built some clouds. My main topics at the moment are energy and healthcare. Anything else is not as critical from an infrastructure perspective, but it is. Behind the scenes, I'm founding a cloud security product company at the moment, and I have some memberships, so Pro Bono, Gaia X, Agi Kritis, and public governmental initiative about a place for public code, and I'm in this IT steering committee in Germany, and this is just for free. So the timeline of Kubernetes. So not much has changed in this timeline since 2019. As you might all know, this is driven by Google, and they had the internal Borg system, which is effectively taking over everything. And they wanted to release the Borg system, and then you had this, they discovered, okay, it's not possible to operate every detail of the system out of the Google infrastructure, and then they released Kubernetes. This is the official part. And the not so official part is the 7 spokes of the Kubernetes wheels are from 7 of 9, who is one of the famous Star Trek characters in the 90s, and she also occurred back in the latest Picard. But this is only for Star Trek fans. So in 2014, we had this Kubernetes release, so it's getting 7 now, it's going to school now, if it would be a child. And immediately you saw a lot of companies interested, so IBM, Red Hat, Docker at that time. And first releases in 2015 attracted other people, for example, Calico, which have built people from Calico, have done the security on the OpenStack network, and they immediately ported their code to Kubernetes, and one of the interesting networking stacks. At that time, there was a telephony project here in Berlin, so we used telephony in Kubernetes, which is quite interesting because at that time the GDPR was not so well developed, and we had to follow German laws, and we externalized the certificates and things like this. But development clusters, design pattern came in 2016. We had Helm in 2016. That time it was heavily insecure. Then Rocket followed because Docker started the container wars, banking started, things like this, and there was this Pokemon event. And yeah, gave my first security training in 2016 because this Helm and these other things have pitfalls, and you should avoid these pitfalls. But this Helm has evolved into this secure now, but we have other interesting things. Secrets encrypted in 2017, role-based access control, which is one of the major things. If you look into the history of role-based access control, it was never meant to be used by humans, and it was for automatic things. Yeah. Pod security policies followed in 2018, audit logging also. Traffic control came interested in this year. Energy trading took off in 2018, and more traffic control in 2019. And nowadays, energy control is delivered in containers. So it's quite important for our energy grid that Kubernetes is secure there. And this is the view today. So we started with this little Pikachu, and now it's everywhere in airplanes. The 5G network is driven by Kubernetes, and trading, banks. The German Gaia X project is one flavor of Kubernetes. Healthcare, energy system, and ships and trains are following. But unfortunately, I have to tell you, all clouds are broken somewhere. If you don't care about it, and if you believe that the standards are secure, you have a real problem here. So, and I will show you why. Because what we have to follow, and what is a very good principle here, is the image from the kernel. You should only use least privileges everywhere. And the kernel has 4 security zones. So ring 0 is the internal ring, which is a privileged one. Then you have a ring for device drivers, 2 rings, and 1 ring for applications. So you should work in the green area and not in the most privileged red area unless you know what you are doing and you have special knowledge about security. And if you don't do it, you are feeding the alligators. And how does it look in Kubernetes? I will tell you. What does it mean, least privileges in Kubernetes? How can we follow these privileges? So let's start. You all know this probably. What is the life cycle of a container in a pod? Normally you have init containers, you have containers of your main application, you have sidecars, and the container is ready if it's ready for services. But ready for services means it could be connected to the outside world, all these people on the internet which try to hack you. And here is closer to reality. I use Java. I have no special flavor. Node.js is one of the problematic things at the moment. Was a talk from Snag about this, and they're doing really the hacking of a Node.js container. But let's assume you have a Java container. I will use this example. And this is the main application. And the main application might have a sidecar for logging or something else. But this does not matter. And in the init container, here, for example, if you are using a database, then database might change some host setting system. CTL is a privileged command, and to use this privileged command, the container here must be privileged. But then you very often see, oh, all the containers, the entire pod is privileged. So the init2 might be uninteresting, but now your main container is running with privileges which are unnecessary. And this means, in principle, if somebody hacks into your main container, you get access to host resources, which is not a good idea. It can be here the sysctl, you can change host settings. It could also be a host port, a file system on the host, and this could be justified in certain cases, but it's not necessary in the common sense. What you can do is you can split the responsibilities. There is no need to expose the host to running main containers. So you identify something which can be separated, and to separate the init system, which, by the way, should definitely be in a daemon set, because otherwise you have not reproducible things. If you have two of them, two daemon sets, then who will win and who will change the host settings if they are changing the same setting? Then you have the problem, the last command wins, and this is not probably what you intended. You will have a lot of fun debugging this, and then you do it in a daemon set. I normally recommend to run it in a privileged namespace, just to separate quite clearly. In our user namespace, there is nothing which needs privileges, and in this my system namespace, we have a privileged command which needs the privileges, but the my system namespace applications should not be connected to the internet. This is what we are doing here. So you are using an init and a pause system. The pause is just that it does not terminate, and then you are done. And now the main application in your user namespace looks much more relaxed. So you have no connection to the host. You can have a connection to the internet. You can have additional proxies, and if you do it quite sensitive, you can use a network policy which only allows internal connections and only well-defined connections. And the init system still stays the same. So we have here separated all things, and you have this port 443 application, and might be connected to port 8080, which is unprivileged because you are doing the 443, so the TLS endpoint somewhere on your load balancer, not in your application. So here we have both examples together. So we have separation of concerns. You have a privileged namespace and the user namespace, and everything is fine. We can sort the application. Do you really need the privileges, or do you have a better way of doing this? So this is first thing recommendation. We have not written a single line of code or YAML. It's just an architectural thing where you definitely can prove for your security audit that you have cared about this, and an auditor can follow your arguments and see, okay, show me your, well, my system daemon said, show me the other things, and then everything is okay. Oh, my wife is waiting for a phone call. Yep. So, and yes. Give me a second. Okay, that's the one. She took the call, and now here we have other things. So this is the worst practice, and this has been fixed. So this is not the recommended way of installing Elasticsearch, because this was from an older version, and now Elastic has definitely changed to this architecture. But still, be careful. You find examples like this on the internet. And here you have the init container, and the init container is doing exactly this stuff. And here you see the command, the sysctl is run by an init container. And here you see the privileged security context to set these things. So this is completely unnecessary, and this should not be used. So please be careful following examples on the internet, because they might be outdated, they might be unmaintained, and then you get unsecure examples. And here are examples for unnecessary privileges. So you have writable containers. You are running applications as root. You are using privileged ports. So in the main example, Nginx, we will see in a few minutes, yeah, Nginx needs these privileges, but you could also run Nginx on 8080, and then it doesn't need a privileged port. You see a lot of netadmin capabilities. I will show you in the Istio example. You see Docker sockets and containers, which is absolutely dangerous if the containers are connected to the internet. Generally, we have missing port security policies, no network policies, and one unfortunate example are the Istio sidecars, which expose Istio by the netadmin capability to become overrun. So should not be done by default in Istio. So here is the example. Normally you find this example on the right side in textbooks and the internet everywhere. I myself presented it in the beginning in so-called master classes. And this is the easy way of doing things. And then the next thing is from Nginx strict. Yes, you don't need it. So please run your Nginx on an unprivileged port, but you don't have to be root inside the container. So this green container, so this left part here does not need the netadmin capabilities or the privileges for the port, and in opposite to the right. So don't follow the examples on the internet, even if they are from the Kubernetes community. So we should be careful on that. How can we heal this? So I will tell you in a few minutes. Istio has another problem. Istio is overhyped, and you see a lot of complexity, security by default, defense in depth, zero trust network, identity policy, AAA, encryption, everything. This looks very nice on a slide, but the implementation, if you look behind the scenes, is the same. We have a privileged netadmin container. And here is the way in Istio is connecting your ports to and from the internet. So you have the ingress path, the egress path, and the port-to-port interconnection. And everything is connected to the Istio envoy, and nobody can change this unless you have set it in through the Istio envoy. You have the mixer, Prometheus tracing pilot. Pilot is doing all the stuff from controlling this, and you have your application containers. What they don't tell you in the documentation, or they try to downplay it a little bit, you have in the beginning you have an Istio netadmin container, which is terminating, and this container is setting the IP tables rules for your application in your namespace, that you only can talk to your local Istio envoy container. And this is a dangerous part because this pod, because this init container in this pod needs net admin privileges, the entire pod can have net admin privileges. And this means if somebody knows this and hijacks this and deploys a container which is exactly doing this, then it can also be from inside a privileged container that you completely turn off these IP tables rules, and that you circumvent the protection Istio gives you normally. And this we will, this is what we will show you in a few seconds. So let's go practical for demo. So I'm normally, this should be a little bit bigger. I can show you the container. So this is running in a Jupyter notebook, and here in a latest Istio, I labeled the namespace. It's already labeled, so I prepared the example. Istio is already running. Let's look into the settings. So we have this special mode that it's registry only. And we see here, this is the way we do the installation. We are using install any, and this means allow any, and this means anything is allowed. Okay, let's go. I think this is just a sleep pod, just to keep it up and live. And you see a deployment here, and the deployment is only used to have a curl inside it, so that we can prove if we can connect to the outside world. So let's deploy these pods. These pods now. Let's see, it's initializing. And we have this pod here. And it's running, and now we have seen this. Yeah, it's open. So we see we have a connection to the outside world. And if we want to block it, we must switch from this allow any directive to the registry only outbound policy mode. This can be done on the Istio CTL command line. Now we have changed the thing, and now this same website should be blocked. Can take a few seconds or a minute. Let's go for it. It's not instantaneous. In between, I'll give them a little bit of time. We can look into the pod. So what we see here is, we see the pod we have deployed is enhanced by an Istio container. You see a lot of Istio values here. You have effectively as a container, that's a little bit, perhaps this one container with this command. And the proxy side. Here you see the proxy side, which is effectively doing the work here for you, logging everything. And here you see now the command gets a timeout. I've set it to no, it's immediate And that's what we are repeating here. So now the rules are set, and we have effectively the assumption that everything is blocked. Here you see the sleep container, which is intentionally only one container. This container only has one connection, has been enhanced by Istio with a sidecar container. Okay, this looks nice. And now Istio took control, everything is normal, and you would expect your application is blocking all this stuff. But now I promised you a hack. We are doing this kind of hack here. So we create an escape container. And if you look here, what simple thing I'm doing is I'm using the fact that this pod can be run with net admin privileges. And the net admin privileges in the namespace, in the network namespace of the Linux network namespace of the pod can be used to turn off the rules. Everything I do here is I output the old rules, then I clear all the rules and show them again. Okay, let's deploy this container. We have this escape container. See, it's initializing. It has 3 containers. Here we are. Let's have a look. What's going on? And here you see we have, it's fully annotated. This is the original payload. Here you see the commands we have done. This looks nice. And it's a little bit lengthy, but this is as it is. And now let's look into the log files, and the log files shows the output. Here we have the rules. So I'm just enhancing a little bit with grep color. And here you see these are the original rules before we turn them off. And here are the rules after we have turned them off. And you see only these targets, how is it called in IP tables? And the rules are there, but they are empty. So this is what we have done effectively. So we switched off the issue protection. And now we can look if we can use this. And yes, it should be blocked because it's in the same namespace. And we can have full internet access even if we should not have full internet access. So this is what we have done here. So the escape container has used simple Linux administrator things to turn off the protection, the Istio protection. Okay. That's what I wanted to show you about Istio. And the question is, yes, you as a developer or an administrator operations, can I find these containers? And really, yes, you can. You can simply do kubectl commands. Just to, oh, the demo was already, and we just can place this in the Jupyter notebook and look for the privileges. So let's just do this. And here we see the escape container has privileges. And you see the net admin privileges. And now we should be aware of that. Okay, somebody has privileges in my Kubernetes cluster, and you should simply ask, is it really necessary? Who is doing this? Do we really want this in that case? This is what we believe that this container should have. If not, then yeah, we should question this. And more or less this is done, it's the same thing which is done by Kubebench or other things which simply look if this is possible and if some containers are here which have this escalation. And I think you would need a low hundreds in scripts like this to make your cluster secure and permanently audit your cluster in a way that you can find all the violations of least privileges in your cluster. Yeah. Okay. Next example, non-root containers. This was the very beginning. I promised you the Nginx, the privileged, unprivileged one. So let's really look how unprivileged this container is. We have now this strict version of Nginx. So it's still under control of Istio. Oh, this was not a good idea to do this example. I made a mistake because now it will be blocked and we cannot download things, but we can simply, yes, have to delete it again and turn off Istio, because Istio now would definitely block. And the good thing about Istio would now block the download of things in at the end. So Istio CTL. Let's do. Let's ask Istio is turn it down, and I need undeploy the Istio system. I forgot to leave the. Let's assume it's something like uninstall, as usual. Where was it? Not really. So let's go. Yeah. Then let's go back. So yeah, it would be a little bit complicated, but I've prepared also the HTML things as backend. So what we are effectively doing here is if we don't control the traffic, you can install the strict version, as I see here. You can see the pods which are running. You create it, you get a local IP, and then you have everything running here. And what you also can do is you can get the pod. And then the main thing you should be aware of is if you have access to a pod like this strict and secure pod, you get here kubectl command, and you can curl. If you can curl to the outside world, you can install it. And the thing is, even if the entire root file system is definitely immutable and you have a temp file system, then you can install your payload here. So the attacker can attack you by installing a kubectl command in the temp directory, and then the attacker can exec this kubectl in the temp directory. Change mod dot plus x should is working here. Then you can exec the pod. You can go into the pod and get working kubectl in the cluster. And now the next thing is you can exec kubectl and try to get connection to the cluster. So this is this command here. And this is normally forbidden because your service account does not have the right to get access to all the pods in your cluster. So this looks secure, but what most people forget is, yes, we have this service account. This is what we use here. Implicitly, kubectl is looking for the service account. And if you are now one step away from disaster, because the service accounts, we have a lot of them, and then you look into the internet, and what you see is, and what you should never ever do, is to bind the service account to the cluster admin. And you see a lot of recommendations. Yes, let's do it here. Cluster admin. Tiller was famous for getting access to the cluster admin. And if you connect your service account to the cluster admin, then you are lost, because now what you can do is the kubectl, which runs inside the container, we are executing into the pod and executing the tempctl. Then you see all the pods here. And now we can run our malicious payload and create a container which is named malicious here. And this means you can control the entire cluster from inside a hijacked pod. And this is the thing you see. You can exec, you can delete other pods, you can get the cluster roles, you can even escalate your roles, you can place backdoors in the cluster, which are hard to detect if you create roles which look like system certificates, something. My own role was here, and then you own the cluster. How can you detect this? So there is a possibility. Yes, you can try simply how many roles or how many accounts are bound to the cluster admin role. And this is the command which would do this here. So you have a lot of things, and the most important one is, please check your cluster that nobody has access to the cluster admin role, if not Nexus. See a lot of things like this. Cluster role bindings, you can see it here. You have this cluster admin binding we have created here. And if you find something like this, and this is unintentional, definitely you have a problem. Here we are checking all the cluster role bindings of D4 accounts, and we find that these accounts and the name of the bindings to these accounts. And here is a command which already, which is again using this JSON path things to get a loop around all the cluster role bindings, and pointing to the roles where they are used, and the name of the role references. So you have the references of things. Here you see what we have done in the cluster. You see the Minikube ABAC is binding the cluster admin role to the kube system default, which should not The kube-system default is okay, but the default is the problem. So the kube-system default, the kube-system namespace is highly privileged, but the cluster admin to the default account in the default namespace should not be occur in your cluster. More things like this. Here are the other role bindings. You can check with a single. Yeah, it's one-liner effective, but it's a little bit complex one line. And here you can find it. Yeah, you can remove the service account token from the container, which is possible, but you can no, it's not, I'm not prepared this, but you can definitely come back again with the service account token. So if it's not here, no, not in this mode, I can go to the service account token. These are all the things I normally do. This is service account token. This is I don't find it at the moment. Service account token. Yeah, don't let's waste too much time with it, but definitely you have this capability of yeah, here we are. This is what I looked for. You can remove and allow the service account token in a pod, and you can get you can remove the service account in a way that that it does not have the service account token. This is another layer of defense, that you don't mount the service account token into your pods, because most of the pods don't need it. They are unprivileged. Most of the pods never will try to control your cluster or even a certain aspect of your cluster. You can do this way, simply deploy a pod with auto-mount service account token. True, this would override the account, but you can simply add it to the service account. This is the line I look for. You can patch your service account that the auto-mount service account token is false. Let's do it. Have the standard account here, and now you see the service account token is false, and you don't get access, but this can be overwritten. You can test it on your own. So this is nearly 45 minutes. So basically what I wanted to tell you, and yeah, demo. Sorry for the glitch. I've done it in the opposite direction. Here in the slides, you will get these. These are the typical things I told you for the sidecar. And good thing is there is a solution not to use sidecars. You can use container network interface, and this is the default, for example, in OpenShift, and should be the default of your vendor or your cloud provider solution. But normally they are quite sloppy with this. In general, yeah, the philosophy you should look into is this DevSecOps from the US Department of Defense. I'll prepare the link for you if you want to solve your security problems on process level, which could be a lot of effort. There is a reference design for it, but in the end, this is a long-term process. So my conclusion, there is no secure by default at the moment in Kubernetes. Some cloud providers and vendors are doing a very lousy job, but Kubernetes in general is getting better. You should care that it can and should be fixed before implementation. And this has impact on architecture, the way you deploy applications, your networking, your identity access management, and again, networking. So I'm open for questions now, and give back to Christoph. And thank you for listening.
Thomas, thank you so much. Really interesting to see what you can and should not be able to do with Kubernetes. So there have been a couple of questions in the chat around where can people get the scripts that you showed? Is there any public access to it?
Yes, I have. Oh, I did not mention it so far. Since Easter, I have a GitHub repository, GitHub Thomas Fricke training Kubernetes security. All the slides I present in my, all the Jupyter notebooks I present in my trainings on GitHub. So if you know how to run Jupyter notebooks, you can use it. And I think we will promote the slides tomorrow.
Yes.
And together with the HTML slide, HTML part and the Jupyter notebooks I've used here. So this is the general overview. But there is much more. If you look deeper into it, I think I can talk days, 5 days without interruption about Kubernetes security, without too much repetition.
Cool, but it's good to know that all these scripts are available. We'll share the link definitely in the email we'll send out tomorrow. And we have a few other questions, obviously. Yeah. So question number one: what would be the safest way to install certificates for Containered on all nodes? The simple solution we tried was to use a daemon set that has the privileges to just alter the nodes and restart Containered. But is there any other way to do this?
Well, certificates, yeah, you can put certificates outside Kubernetes. So a lot of people are using Vault for this, which is a quite good solution. But then you trust in Vault. You can also use hardware security modules, which are not under the control of your cloud provider, but this is a very let's say, sophisticated solution, and you have to do a lot of things. So you can keep your certificates, your secrets outside, but then you are on a security level where you really have to care about it and you have to prepare it. You can do a lot of things like this, and you could have, for example, special hardware is sometimes recommended by certain frameworks, PCI DSS or other frameworks, and it's possible, but you should be aware that there is a situation where you simply have to pull the secrets into Kubernetes.
All right, thanks for that. Then we have another question. What do you think about projects such as Kyverno, and do you know any other projects that could help on some of the things you showed?
There are a lot of projects there. I think there are a lot of vendors like Aqua Security. I did not mention them all. Sysdig, Octarine was one of these where I've worked with before they have been bought by VMware. And you should look into it. What I would definitely recommend, start with is Kubebench and look into it. And then you are quite busy for a few weeks, I think. And then try to get more and more control on the cluster. We have a lot of solutions. You can make Kubernetes quite secure. Even you can, if you believe in Red Hat, OpenShift is quite a secure solution, but it's very expensive. And not everybody likes IBM and Red Hat, but this is more or less a religious question.
Yes.
So if your religion is red, then this might be a solution, but it also does not solve all the problems. We see problems. What we did not touch here, for example, is resilience, how to set up a cluster things like this. So there are a lot of best practices, but not all of the best practices are obvious, and probably you need not only to read the internet, and we have seen you get distracted sometimes. You have to understand your cluster, and you need somebody who also has the understanding of the underground, the Linux underground under Kubernetes is still important here.
Okay, thanks for that. What about containers that need special VPN access? So basically need netadmin. Are there any general recommendations?
Yes, you can run them in special. So there is, you see this example from this WireGuard example, how to install VPN. Then you have a special container, and this special container uses VPN, and you can use it. You need netadmin, but you should not have anything else in that container. So it's you have a privileged container only, and ideally you should look for a framework which does not do this in a container which can be turned off. You should try to use it through a solution which is using the container network interface. This would be preferred. If this does not work for you because you need only one container, then it could run you could use a sidecar container besides your container, and this container needs privileges and all the other containers don't need it. But then you have to protect this container in a very special way. Mm-hmm. It's a little bit complicated to do this, but definitely it's possible.
Can be done. All right. Cool. We have another question. Can all the threats to the pod security context be dealt with by improving the pod definition, or is it also necessary in some cases to update the container image?
The container image is one part. So normally, if you look into the guidelines for container hardening, most of the hardening is done for the container image. So you should regularly exchange your containers. So you should have a process which detects vulnerabilities in your container. If you look, for example, in this Harbor registry, it does it automatically. Yeah, the pod definition is sometimes, if you look into it, the pod definition has no, or Kubernetes has not really learned to be secure by default. For example, if you see the service accounts, there is no need for these tokens. Most of us will never use these tokens inside a container, and people are learning this. But instead, Kubernetes is a little bit developer-driven, and then you see developers tend to add more debugging instead of more security at the moment. And debugging also means if I can debug something, it's probably not very secure. So the entire process in Kubernetes of how to increase security in Kubernetes should be improved, and developers should be a little bit more careful about this. So we need more system engineering mindset, not this hipster mindset, oh, let's scale it and things like this. So system engineers are more aware of security. In a team, this is what normally I tell people about DevSecOps. You should also have security engineers somewhere. Okay. They are as important as designers if you are working in a secure environment, but they are not enough of them.
All right, understood. So the call for more system engineers. We have one basic question. So to run the Jupyter Notebook for kubectl, do we need to run the Jupyter server on the Kubernetes?
You can do, but it's not necessary. It's not absolutely necessary. If you use Minikube and look deeper into Minikube, you find that Minikube actually is a full-blown Ubuntu 20.04 in a container, if you use a container solution. And then you can install inside Minikube the Jupyter notebooks. This could be interesting for special things. But here I have run the Jupyter notebooks outside Minikube. And this has a lot of advantages. But you can switch wherever you want. So you can run it in containers or outside, depending on what is more comfortable for you.
All right. We are planning to use port shift for container security in Kubernetes. What do you think of it?
Port shift is, can you explain it a little bit?
I don't know. That's the question I got here. It's Cisco software, Cisco.
I would stay away from Cisco. Simply because I would stay away from everybody who is delivering backdoors as a service, and please stay away from Cisco until it's completely open source. So if port shift is open source, then I see it's on the Red Hat marketplace, it's open source.
I think they just
but monitor it, and if it's a proprietary software, I would buy anything from Cisco. In opposite to most of my customers who are definitely using it, but yeah, you have to audit the source code to look if they do not deliver backdoors.
Okay, understood.
This is my opinion about Cisco. And
Thomas, thanks for sharing. Thank you so much. I think we've been through the questions. It has been great to see you working on all of this. So as I said in the beginning, there'll be a recording of this, which we'll share tomorrow. We'll share the useful links to your GitHub repository for sure, to make sure that people can start playing with this. So thanks again. Thanks everybody for attending, and have a great evening or day from wherever you joined.
Thank you, Christoph, and all the guys from Humanitech for organizing this. And
has been a pleasure.
Have a nice evening or have a nice day, whatever.
Thomas, thank you.
Thanks.